This video is on combining ions to write the formula for a compound. Before we can talk about that, though, we have to quickly review valence electrons and charges or oxidation states for groups on the periodic table. Make sure you're taking good notes as you do this, and make sure you have your periodic table out. So valence electrons, I'm going to draw them in green. They're the same for each group. So the alkali metals and hydrogen, they all have one valence electron. So that's why hydrogen is put there, even though it's a non-metal. So the alkaline earth metals, they all have two valence electrons. The transition metals, so this whole middle group, the D block, they have varying amounts of valence electrons and charges that they can have. So we're going to come back to them when we talk about charges and formulas more in a little bit. So we skip them, so we're going to have 3 valence electrons for boron's group, 4 for carbons, 5 for nitrogen, 6 for oxygen, 7 for fluorines for the halogens, and 8 for the noble gases, except helium is going to only have 2. So if you remember this is the trend, 1 through 8, and they're trying to get to 8. So in order to get to 8, they're going to gain, lose, or share electrons. So its charge, or its oxidation state, the first group, the alkaline metals, and hydrogen, they're going to lose their electron to share it. And so their charge, when they lose a negative, is going to end up being +1. It's really important that you know these charges because that's how we decide how many of each element are in a compound. So the alkaline earth metals have 2 valence electrons. They could get 6 or lose 2. They're going to lose 2. So that underneath, their new valence level now will have 8. So they lose 2 negatives, they end up with a +2 charge. The middle now, they have variable charge, which means that they all have different amounts of charge. These are going to be told to you, or you're going to be writing them through a Roman numeral. Okay, so we'll be going through this more in the next video. Boron, aluminum, this group, they're going to end up with a +3 charge because they're going to lose 3. And carbon's group, really, they could gain or lose 4. The nonmetals in this group are going to share, so they're not really going to have a charge anyway. The 2 down here, tin and lead, they act like transition metals, so they have this variable charge. So we're going to talk more about them also in the next video. So nitrogen's group, they're going to gain 3 electrons to get to 8, so their charge is going to be -3. Oxygen's group, they're going to gain 2 more, so their charge will be -2. The halogens gain 1, so their charge is -1, and the noble gases don't want to gain, lose, or share anything. So we're going to use these charges to combine elements, or to combine ions, really. So combining ions are due to cations and anions and how they're attracted to each other. So cations are your positive charge, and anions are your negative charge, so opposites attract, just like magnets. So when this happens, we get an ionic bond. So we're going to talk about compounds that are ionic. So in writing these combinations, the charges need to balance. Okay, and I put it in quotes because that's just kind of my term. Or they need to technically add up to 0. And the reason they add up to 0 is compounds don't have a charge. So that means they have to balance out. The positive and negative have to be opposite sign but same amount. So to get that to happen, you may have to multiply or have different numbers of each ion in your compound. Like H2O, there's 2 H's for every 1 O. Okay? And when we write them, it does matter the order of your ions. The cation always goes first. There are a couple exceptions to that, but we'll get to those later. So for now, just think cation goes first. So let's do a bunch of examples for this. And this should help explain it. Alright, so make sure you're writing all of these examples down, because that's really going to be what helps you the most. So the first one, excuse me, so if we have potassium, and we're going to combine it with bromine. Okay, so we have to know their charges. So you look at the periodic table, and you say, okay, K is a +1 charge. Okay, so in the first group, bromine is a -1 charge. So I'm going to go back to here and I'm going to write +1 and -1. Okay? So what's happening here is our charges need to balance out. So you could think of this as them adding up to 0. So a +1 and a -1. When you add them up, you get 0. So what that means is you need one of each of these to write your formula. One potassium and one bromine, when they combine, they add up to 0 their charges. So your formula is KBr. One of each. We don't write ones. Okay? We just leave nothing written. So let's do another one. Let's do magnesium and oxygen. Magnesium, oxygen. If you look at the charges on here, magnesium is +2, oxygen is -2. So Mg is +2, O -2. When you add these up, you get 0. So that means you need one magnesium to balance out one oxygen. So your formula will be MgO. Okay. Let's do another one now where they're not the same number. So let's do Ca and Cl. So you look up calcium, it's a +2 charge. You look up chlorine, and it's -1. So now, these do not add up to 0. Okay? So what you want to do is, to get them to add to 0, you can multiply them by something. Okay? So, what do you need to multiply them by? Well, you have a +2 right here, and you need to get this one to be a -2. Opposite sign, plus and minus, but the same amount. So how do you get -1 to be -2? You multiply by a 2. That means you need 2 chlorines to balance out your 1 calcium. So your formula would be CaCl2. So we show that there are 2 chlorines with a subscript, sub meaning below, or under, and that number right there. So 1 calcium needs 2 chlorines to balance it out. Okay, and this is what we did last chapter. When we drew this molecule, we would have drawn this as Ca, right, with a chlorine bonded on either side. And many of you already figured out, like, oh, calcium would need 2 chlorines because it has 2 valence electrons to bond, 1 for each chlorine. So let's do another one. Let's say we have Al, which is +3, and oxygen, which is -2. Okay, in this case, same deal, we're trying to get them to add up to 0, so we're going to have to multiply them by whatever to get to that point. Well, I can't just multiply one of them, because the numbers you multiply by, these numbers, need to be whole numbers. So that means no decimals, fractions, anything like that. So I can't multiply -2 times 1.5 to get -3. I need to multiply it by a whole number. So I'm going to need to get the 3 and the 2 to be the same number, and I'm going to go with the smallest one that they could both multiply into. So it's kind of like in math when you did fractions and you're trying to find the lowest common denominator. The smallest number that 3 and 2 multiply into is 6. So to get +3 to be, I want them to be +6 and -6, because that's will add up to 0. So +3, if I multiply by 2, I get a +6. -2, if I multipy it by 3, I get a -6. So that means for my formula that I have 2 aluminum. So I write Al2 and 3 oxygens, O3. Okay. Another way to look at this that many kids like to do is to do this, to do your formula or the charges for the ions. And what a lot of kids do is they say, well, 6, that comes from 3 times 2. So what they do is they say, well, this number right here for oxygen, that 2, not the negative, but just the 2, that's going to be the subscript for aluminum. And this number here for aluminum is going to be the subscript for oxygen. So you get Al2O3. So basically you're crisscrossing the charges. Okay? That works almost every time, but you have to be careful sometimes. For instance, if you had Pb +4 and S -2, Okay? If you crisscross them, so if you put the 4 here and the 2 here, technically that wouldn't be correct. You would get PB2S4. And the reason it's not is you need to be able, if you can reduce it, you should. For instance, your math teacher would probably mark 2/4 incorrect because you should be writing 1/2. Both of those numbers, 2 and 4, can be divided by 2. So you should be writing, cross this one out, you should be writing PBS2. 2 divided by 1 is, 2 divided by 2 is 1, that's why it's 1 lead. 4 divided by 2 is 2. So if you did it the other way we were doing it, if you looked at these two and said, what do they add up to get to 0, you have to multiply this times 2 to get your formula. So PBS2 is the correct answer. Okay. Let's do just maybe one more. How about Ca, which is +2, and phosphorus, which is -3. Pause the video, try this one, and then we'll go through it. So for this one, if you add these up to get to 0, you're going to have to multiply them both. You're going to have to multiply the 2 times 3 to get a +6. You're going to have to multiply the 3 times 2 to get a -6. So your formula would be Ca3P2. You could also think of this as crisscrossing, so this 3 becomes the subscript for Ca, and this 2 becomes the subscript for P. This is how you combine ions in ionic compounds to write the formula for a compound.